over here. Okay? The record function causes the smartboard to move at a slightly slower pace. Which arrows should I fill in? Oh, and I heard 120 newtons. What do I label that as? You heard inside. Okay, excellent. What else? Careful, because this is pulled at an angle. Diagonal, I'm just going to put it this way because I have a little more room. Okay, and I'm actually going to switch colors here because we have an applied in the X and applied in the Y. And this is 25 degrees here. I'm going to label my force here, 35, or right, 30 newtons? 30 newtons. Force. Okay, just so that I don't forget that I have a force of friction. Okay, I don't know the value. But remember, I don't know the value of it yet. Cosine? 27.2 newtons, okay? Okay, so force applied to Y equal to sine 25 times 30, which should get you a value equal to X. I'm going to write that as an equation. Weight should equal force applied in the Y plus the support force. Okay, I know my weight is 120 newtons. My applied force in the Y I just figured out as 12.7 plus the normal force. My normal force, 120 minus 12.7, 17. You know, if you drop the 0.3, that's fine. Find the normal force. I found the normal force. And then I need to solve for acceleration. So force of friction is equal to mu times normal, which is equal to 0.25 times 107.3. Okay, how do I find the net force in the x direction? I know force of friction is 26.8. If I look up here, I know that force applied in the x is 27.2. What could I do to find the total net force in the x direction? Force in the x equals, kind of is a subtraction problem, so FAF minus force of friction, just because they're acting in opposite directions. Okay, from here, I know my applied force is, what is my applied force in the x again? 27.2, thank you. Minus my force of friction, which I just solved for as 26.8. That's my net force in the x, and since we're only talking about its acceleration in the x, that's what I'm going to use. So my net force in the x direction, 27.2 minus 26.8. You're coming up with a pretty small number of 0.4 newtons. That's my net force in the x, and then ultimately I want to solve for my acceleration. So remember, net force is also equal to m times a. So I have 0.4 newtons is equal to 12 kilograms of mass times my acceleration. And then we solve for acceleration.